Hello, welcome to another video about heat transfer. In this video we'll be looking at convection. So as with conduction, in stage 1 physics you'll need to be able to explain how heat transfer can occur through convection, and you'll need to be able to describe examples of this heat transfer process. So definition first, convection is the transfer of thermal energy within a fluid by mass movement of particles from hot areas to cold areas. First thing I want you to do on your handout is make a note that fluid can refer to a molten solid. It can also obviously refer to a liquid, and it can refer to a gas as well, so it could be referring to any one of those things. So you'll come across a lot of diagrams where you've got some warm arrows pointing up or some red arrows pointing up, and then some cold or blue arrows that point down. And I want to dive a little bit deeper into what's actually happening here. So when something is heated, particles gain kinetic energy. Because they've got this extra kinetic energy, their vibration increases, so these particles push apart from each other. Because they're pushing apart, the density of the heated fluid decreases because there's more space in between each particle. As a result, the fluid is lighter and it therefore rises above any fluid that is not as light. And so particles in colder fluid, because they vibrate less, their fluid is less dense, and then therefore their particles are closer together. So as the heated fluid is rising, the colder fluid falls because it's just more dense, so it has to fill this place that is left behind by the less dense rising fluid. So in our kettle, as the water near the heat is warming up, its density is decreasing, it's therefore becoming lighter, so it floats or rises above the colder water that is further away from the heat. The colder water sinks down because it's more dense, and it takes the place of the water that's like risen from the base where the heat is, and then this process continues. Convection currents occur when warm fluid rises and cool fluid falls, and these cause upwellings in the ocean, they cause winds and weather patterns. So for example, with winds, during the day, land is warmer than the sea, and the air on land tends to rise because it's getting warmer as a result of being closer to the warmer land and the sun, or the land that has warmed up from the sun. This warm air rises and as a result leaves like a temporarily empty spot, so the cooler sea breeze flows in to fill this spot because otherwise it would just be like empty air. Conversely, at nighttime, land is a bit cooler than the ocean, so the reverse happens. The air tends to rise over the seas, and the breeze from the land, or the cool air from the land, flows out towards the sea. So this is why it's so windy on the coast. So as an example, you might need to explain the process of convection in a kettle. So how you would do this and write this on your notes is you'd first say that the temperature difference is produced by an element heating water molecules. So the element that is like in the base of the kettle, the water molecules around that element will become heated first. These molecules will push apart from each other due to their increased vibration, they'll therefore become, or the water in that area, the heated water, will become less dense as a result of this push apart from the molecules, and that water will rise above the water above it, which is now less dense than it. This cooler water, as I just said, is more dense. It falls, taking its place to be heated, and these convection currents will flow until there's no temperature difference within the liquid. So this is what that looks like. It's important that the element is at the bottom of the kettle, otherwise convection currents will only flow near the top without heating all of the liquid, and this is because water is a poor conductor, as we learned in our previous video. So if the element is near the top, those convection currents will only flow between the element and the top of where the water is, because all of the water underneath will still be more dense and therefore won't rise to join in with the convection current. Another example of this is an element heating up an oven. It's pretty much the same thing. It's just air as the fluid rather than water. And even a radiator heating up a room is, like an old school radiator, is another example of this. Another example is explaining the convection currents at the equator and poles of the Earth. So obviously the temperature on Earth is a lot warmer at the equator, so the air of the equator at the equator is warmed by sun transferring heat, and this is the cause of temperature difference. As a result, convection currents flow between the equator and the poles, where air flows upon cooling. So air rises at the equator and then drops, and as it cools, it drops towards the poles. The cooler air from the poles flows to the equator to take the place of that warmer air that has risen. And this is the cause of southerly in the southern hemisphere and northerly in the northern hemisphere winds. So that air from the poles flowing in towards the equator to take the place of the air that's risen from the equator. Another example could be tectonic plates. Scientists hypothesize that the tectonic plate movement is caused by convection currents flowing within the mantle of the Earth. So molten magma transfers heat as it flows between the really hot mantle and the cooler surface of the Earth. So as the magma becomes warmer and warmer, it rises towards the surface of the Earth because its density will be less than cooler magma. Then because the surface of the Earth is a bit cooler, that magma that has heated and risen will then become cooler itself, so its density will increase as its particles have less kinetic energy, and then it will drop back down. So there's that cycle that occurs. And it's hypothesized that this cycle and this motion of the magma might pull tectonic plates under each other